We will start at 3 p.m. exactly. Good afternoon, everyone. I'm your host TA. So we'll be discussing some problems regarding this week one session. So I'll just wait for a couple of minutes. We'll just wait for some other guys. So I'll be discussing with you the problems that will help with your weekly assignment. So in case of any doubts regarding the question, I'll be giving you some time. So you guys can type in your question regarding that problem in the chat box. So we'll just wait for a couple of minutes. Maybe some other guys will also join. People are joining. I think we should wait for a couple more minutes. So I think we should start. We have waited for 3 minutes. I think we should start. So let me just share the screen. Wait a moment. So let me just give a brief introduction. People are joining again. Let me just admit them. So my name is Musab Rafiq. I'll be your course TA. I am a PhD scholar at the Department of Electrical Engineering at IIT Kanpur. So this is the course of digital circuits. Professor Santanu Chattopadhyay is your course instructor. I'll be discussing some problems related to the week one tutorials, so that it will help your with your weekly assignments. We have some 10 to 12 problems that we'll be discussing, and after every problem I'll give you some couple of minutes to type in your doubts regarding that problem. So you can use the chat box feature of the Google Meet where you can type in your doubts. Just a moment, I'll admit some people here. So now I'll be admitting the rest of the people after I'll solve the first problem. So you guys have gone through this number system thing in this week one. We'll be discussing this first problem. The first problem here is that, just need to check. Okay, audio is working. So the first problem here is this: convert the binary number 10111101 to an octal number. So octal number, as you all know, is a number system which has a base 8. So how will we proceed to this question? We will first convert this number, octal number. We'll first convert this binary number to a decimal number, and then we'll convert this decimal number back to the octal number. So 10111101 in decimal can be written as like this. So this is 2 to the power 0 multiplied by 1. That is the this is the phase. This is the value here 1, and this is the position 0th bit. Then we have sorry for the hiccup. Then we have this at the first bit, that is 2 to the power of 1 multiplied by 1. Then we have at a third bit, that is here, which is also 1. Then we again have this, sorry, here it should be 0, 1, 1, and another 1. Then we have, so I'll just change it. 1, this is second bit, this is third bit, and this is fourth bit. Then we have 0, and finally at the sixth bit we have 1. So this is equal to 2 to the power 6 is 64, then plus 0, because here we have 0. Then we have 2 to the power 4, that is 16. Then we have 2 to the power 3, that is 8. Then we have 2 to the power 2, that is 2, but that is 0, bit position, occupying position 0. And we have this 4, and finally we have this 1. This is equal to, if I am, if you can use this calculator, this is 64 plus 16 plus 8 plus 4 plus 1, so it is 93. So the number is 93 in decimal. Now we have to convert this 93 in decimal into octal. Question is asking us to convert it into octal. So we have this 93. To convert this number 93 decimal number into octal, we first divide it by this base of the number system, that is 8. Octal system has base 8. So we know this 8, 11 is 88. So we will be having the remainder 5. Then we have this 8, 1 is 8. 11 minus 8 is 3. Then we will have this remainder 3. So our number in octal system is 1, 3, 5. So the number in octal system is 135. So the correct option is option A. So if you have any doubts regarding this question, you can just type in the chat box, and also I'll be admitting some other students here also. I'll just wait for a couple of seconds. So I can see that someone has typed that he has no doubt, he or she has no doubts. So we can proceed to the next question. The next question here is, we have this, so I think I have some message. Yeah, you can take that. I'll be just showing later on that. So this is the elaborative method. You can do that. You can do that. That certainly is an option, but this is a more elaborative way. So yeah, I can explain once again. No issues. So we have this binary number 10111101. What I did is I first converted it into decimal system. So what I did is at every bit quotient we have this 2 to the power 0. This is 0, 1, 2, 3, 4, 5, 6. 2 to the power 0 multiplied by the value occupied by that quotient. This is 1. This is 0. This is 1, 0, 0. So when I evaluated this 2 to the power 6 is 64. 2 to the power 5 is 32 multiplied by 0. That is again 0. 2 to the power 4 is 16 multiplied by 1. 2 to the power 3 is 8 multiplied by 1. 2 to the power 2 is 4 multiplied by 1, and 2 to the power 1 is 2 multiplied by 0 is 0, and 2 to the power 0 is 1 multiplied by 1 is 1. So when I added up this, so it came out to be 93. So we have this 93, which is our decimal number. So we can convert this decimal number into an octal number by simply dividing it by the base of the number system. The base of the number system here is 8. So 93 divided by 8, we have this 8, 11 multiplied by 8 is 88. So 93 minus 88, we have the remainder, that is 5. Now again we will divide this number 11 by 8. It is 11 divided by 8 is 8 minus the remainder part, that is 3. So our decimal number, our octal number is 135. So yeah, Aksharpat, I can show it later. I'll show it later. So any other doubts? Yeah, you can turn off your microphone as there are a lot of participants. You can type in your doubts or any reply to my questions directly in the chat box. We can move to the question 2. So we have this hexadecimal number BCA, and we want to convert it into this decimal number system. We want to convert this into decimal. So what we will do here is, we have this again, just like we took the approach in the previous. There was base 2. Here it is base 16. A we know that A 0 to 9, and after in hexadecimal number system we have 16 digits starting from 0 to 9, and that number 10 is represented by A, then followed by B, C, D, E, and F. F represents 15. So 0 to 15 we have 16 digits. So BCA is our number. So we'll convert it into decimal system. We'll multiply this A. A is our decimal number, has a decimal number here, which is A multiplied by the position it's occupying, that is 0th bit, and the base of the number system is 16, so it is 16 to the power 0. Then we'll add this to C multiplied by 16, which is occupying the base, position 1, and then we have this B, which is occupying the position second bit to the power 2, 16 to the power 2. So we know that this B here means 11. 11 multiplied by 16 square is 256, if I am not wrong. Plus this C is 12. 12 multiplied by this 16, and finally we have 16 of course 0 is 1. This simply the number a, that is 10, and if we'll add them up, this 256 multiplied by 11, 256 multiplied by 11 is 2816, plus 12 multiplied by 16 is I think 12 multiplied by 16, how much is that? 2816 plus 2816 plus 192, 2816 plus 192 and plus 10. So our decimal number is 3018. Option B. So option B here is our correct answer. So any doubts regarding this question? You can see no. So I'll proceed with the question 3. Yes, someone is joining the meet. Or shall I admit them? Okay. Now moving forward to this question 3, we have these two hexadecimal numbers VA3 and 5DE. So question is demanding us answer in hexadecimal as well as in decimal. So what we'll do is we'll first find the answer in decimal numbers, hexadecimal number system, and then convert that hexadecimal number into the decimal number. So we have this BA3 number here, BA3, and this is in the hexadecimal. Take care of that. And we have this 5DE. So E, as I showed in previous slide, means 14. So we have this 14 plus 3, 17. But 17 in hexadecimal can be written as 16, 1, 1. So 17 in hexadecimal system is 1, 1. So we have this number 1 and 1 will go to carry. Then we have this A. A means 10. So 10 plus D means 13, 23. 23 plus this 1 carry means 24. So 24 in hexadecimal is 16 multiplied by 1, and 24 minus 16 is I guess 8. So this is 8. So the number is 1, 8. 8 will come here and 1 will go to carry. Then we have this B. B means 11. 11 plus 5 is 16. 16 plus 1 is 17. That was 1, 1. So the number in hexadecimal is 1181. So the answer in hexadecimal is 1181. Now we have to find the decimal part. So we can convert this 1181 into decimal. So how will do it? Just like previously, we'll just find this 16 to power 0 multiplied by 1, this one. Then at the second position, at the first position, sorry, 16 raised to power 1 multiplied by 8. Then 16 raised to power 2 multiplied by 1, this one. And 16 to power 3 multiplied by 1. So 16 cube is, I think I have written it somewhere, 4096 plus 16 square is 256. 16 multiplied by 8 is 128, and this is 1. So if we'll add them up, 4096 plus 256 plus 128 plus 1, so you'll get your answer, that is 4481. So 4481 in decimal. So our answer is 1181 in hexa and 4481 in decimal. That is option C, 1181 in hexadecimal and 4481 in decimal. So we'll take that option. So any doubts regarding this question? Yeah, I can repeat. So some people are joining in. I'll just wait for a couple of minutes so that they can also listen to this question. And Jayanti, I'll repeat, no issues, but some people are joining in late, so I'll wait for them. Yeah, I will quit. No issues. So the question was demanding us to add two hexadecimal numbers BA3 and 5DE. So I have written this BA3 and 5DE. E, as you can see here, means is 14, and 14 plus 3 is 17. But 17 in hexadecimal is written as 1 1. So I have written this 1 here, and the other one goes to carry. And A is 10, this 10 plus 1 is 11, and D is 13. So this 11 plus 13 is 24. 24 in hexa is 1 8. So I have written this 8 here, and 1 goes to carry. B is 11, 11 plus 1 is 12, and 12 plus 5 is 17. So 17 is 1 1. So our answer is 1 1 8 1 in hexadecimal system. Now the question is also demanding us to convert this hexadecimal answer in decimal number. So we will convert this decimal number. So we take up the base raised for the position multiplied with the value at that position. So what I have done is there 16 raised power 0 multiplied by 1 plus 16 raised power 1 multiplied by 8 plus 16 raised power 2 multiplied by 1 plus 16 raised power 3 multiplied by 1. So the answer comes out to be 4096 plus 256 plus 128 plus 1, and when you add them up it is 4481. I hope you got it. So we can move forward to this question number 4. Question number 4 here has given us this equation where this number 123 is in number system base number system 5, and we have this another number where this digit is x and another digit is 8 in the base number system y. So people are joining in so they can take part in this question. So now what I will do is I will construct an equation. I'll just convert both the numbers into their decimal counterpart. So I will do this multiply this by base raised to power the position multiplied by the value at that position. So it is if we can show 1 is occupying position 5 is a base system is at position 0 1 2 plus number 2 is occupying position at bit position first, and then we have this number 3 which is up to 0th position. Sorry, minus 0. So this is equal to the left hand side where the base is y to the power 1 multiplied by this position x is there, plus y to the power 0 multiplied by 8. So when you evaluate it, it is 25 plus this is 10 plus 3 equal to this is xy plus 8. So it comes out to be left hand side comes out to be 25 plus 10 is 35 plus 3 is 38 equal to xy plus 8, and the final equation comes out to be xy is equal to 30. So the possible values that it can take is x equal to 1 and y equal to 30, x equal to 2 and y equal to 15, x equal to 3 and y equal to 10. Now the next possible combination that gives us the xy equal to 30 in integers, positive integers, is x is equal to 5 and y is equal to 6. But y can't be equal to 6 because you can see this number here 8. So the y cannot be less than this number 8. So the minimum value of y that we can go is 9. So the only possible solutions are these three. The value of y cannot be less than 9 as 8 is present in the y base. So we have only three possible solutions, which means our option A is correct. A equal to 3. So I'll just check if anybody has come. So any doubts regarding this question number 4? Yeah, I'll explain. I'll just wait for anyone joins. I'll explain. Sure, sure. Just a couple of minutes. Some people are joining, that's why. So I'll explain again. So we are giving this. So someone has joined. So we are giving this equation 1, 2, 3 to the base 5 is equal to xa to the base y. So what I did, I converted both numbers into decimal number system. So left hand side out came out to be 38 and right hand side came out to be xy plus 8. Then when I solved this equation, it came out to be xy equal to 30. So the product of these two x and y should be 30. So I took up three possible solutions in terms of integer values: x equal to 1, y equal to 30, x equal to, sorry, I should write here, wait, x equal to 2, y equal to 15, and x equal to 3, y equal to 10. So the next possible solution should have been x equal to, so next solution that would have been there should have been x equal to 5 and y equal to 6. But y can't be equal to 6 because the value of y cannot be less than 9 as 8 is present in here. So because 8 is present in y base, so it has to be greater than 9. So that's why uh, there are only three possible solutions. So now I think I've explained it again. We move forward to this question 5. So this question 5, we have given this number 110.011. So we have to convert it into decimal part. So we'll do again whatever. So next someone has joined in. Let me admit him. So what we'll do, we'll again do the same thing that we have been doing in the past. So here it is 0, 1, 2, 3. So 2 to power 3 multiplied by 2 to power 3 multiplied by 1 plus 2 raised to power 2 multiplied by 1 plus 2 raised to power 1 multiplied by 0 plus 2 raised to power 0 multiplied by 1. And now we'll do the part coming from this right hand side of the decimal point. So here it is written as 2 to the power minus 1 multiplied by 0. It is outgoing this, the value here is 0, plus 2 to the power minus 2 multiplied by 1 plus 2 to the power minus 3 multiplied by 1 plus 2 to the power minus 4 multiplied by 1. So it comes out to be, this is 8 plus 2 to the power 2 is 4 plus multiplied by 0, so it is 0, so it is 8 plus 4 plus 0 plus 1 plus this is 1 by 2 multiplied by 0, that is 0, plus 1 by 4 plus 1 by 8 and finally 1 by 16. So this is 8 plus 4 is 12, 12 plus 1 is 13, 13 plus 0.25, 1 by 8 is I think 0.125, and 1 by 16 is 0.0625. So if we will add them up, it is 13.4375. So the option D will be our answer. Okay, you just type in here. I have already said that there are lots of people, so it will create a problem for us. You can type in your doubt. Yeah, please type in the chat box. So someone had a doubt, so kindly type it. I think so. We'll comment later. If you have any doubt regarding this, we can show it later. So moving to the next part, next question. Sorry. So we have this number 205. It is in the system octal system. Octal here means to the base 8. So and we have to convert it into binary. Here I will show that that you were saying that why don't we take up three bits and convert it directly. I'll show that way here also. But let's just take up the elaborative way. First we will convert it into decimal number. This is the elaborative part. So the decimal number here will be base, that is 8 raised to power the position 0 multiplied with the number it is occupying 5 plus 0 plus 2 multiplied by 8 square. 8 square is implies 8 square is 64. 64 multiplied by 2 is 128. 128 plus 0 plus 5. So the number in decimal is 128 plus 5, that is 133. Now we will convert this number 133 decimal into this binary. So how will we do it? We will just divide successively by the base of the number, that is 2. So 265 is 130, so 266 is 132, and the remainder will be 1. Then we have this 2 multiplied by 33 and remainder will be 0. Then we have this 2 multiplied by 16, that is 32, remainder is 1. 2 multiplied by 8, remainder is 0. 2 multiplied by 4, remainder is 0. 2 multiplied by 2, remainder is 0. And 2 multiplied by 1, remainder is 0. So our number is, we have to just write from here, 1, our number is 100000101. That is option 1. I'll show you the another way of directly converting this octal number to this binary. Take up this individual digit and find its 3-bit decimal binary equivalent. Take up individual digit and find its 3-bit decimal equivalent. Sorry, 3-bit binary equivalent. So 5 has this binary equivalent of 101. 0 has a 3-bit binary equivalent equal to 000, and 2 is written as 10. So our number is 100000101. That is option A. So any doubt regarding this question? I can see no questions here, so let me just proceed to the question number 7, I guess. Yeah. So the 7 is another conversion question. So here we are given this decimal number 1228, and we have to convert it into hex, and this that is the base system 16. So what we will do is we divide it by the base of the number, base of the system. Sorry, 1228, and divide it by 16. So 16. So let me just take a guess here. 16 multiplied by 70 is 1120. So 16 multiplied by 75 is 1210, plus 16 is 1216, plus 16 is 1232. So 76. 16 multiplied by 76, that is 1216, minus the 1228. So the remainder is 12. So this is 76. 16 multiplied by 76, and we get the remainder 12. Now divide 76 by 16. So we know the 64 is 32, 32 is 64. So 72 minus 64 is 8, so this is 16, sorry 76 minus 64, 76 minus 64, it is 12. So the number is 74, it is 4, 12, 12, and this 12, 12 in decimal system, sorry, hexadecimal system is represented by CC. So our number in hexadecimal system is 4CC, and that is option A. So any doubt in this question? Yeah, I will explain once again. I'll just wait for 1 minute. People are joining in at any time, so I don't want them to miss out. So we are given, yes, so we are given this as number 1228, that is 1228 in decimal number system, and we are asked to convert into the hexadecimal system, that is base 16. So what I did is I took up this number and divided it by the base of the number system, that is 16. So I found out that 16 multiplied by 76, when I do it and I subtract it from here, I get the remainder 12. And when I divide this 76 by 16, I it is sorry 76 divided by 16, we get this quotient of 4 and remainder of 12. If I divide it again by 16, it is 0, so that is redundant, so no need to write it. I'll get 4 here. So my number is 4. This 12 is in hexadecimal system is written as C. So my number is 4CC. That is option 1. I hope I am clear. And you can just type in if you got it. Okay, so we can just move to the next question. That is question number 8. Question number 5, 6, 7, 8. Yeah, question number 8. So this question 8 asks us to add these two binary numbers. It has also some decimal part, 110.01 and 1.01. So what we can do here is we'll just first match them in one column. That will help us in the addition. 110.01. So plus we can just write the other number as, we can just fill in the spaces with 0 and 1.011, and we can just fill in this space with 0. So now we can do this simple addition of binary addition. So this 1 plus here, first concentrate here from this right hand side. 1 plus 0 plus 1 is 1. So I'll just draw it easy. So this 1 plus 0 is 1. 1 plus 1 is 2. 2 in decimal is written as 1 0. So 0 will come here and 1 will go to remainder. Sorry, carry. 1 will go to carry. So this is 0 0 plus 0 plus 1, that is 1. Now we will have a decimal point here. Then we have this 1 plus 0 is 1, 1 plus 1, 1 plus 0 is 1, and 1 plus 0 is 0. So our answer will be 111.101. And the question also asks us to convert this number into the decimal part. So decimal number system. So how we can do it? We can just write it as 2 to the power 3, 2 to the power 2, 2 to the power 2 multiplied by 1 plus 2 to the power 1 multiplied by 1 plus 2 to the power 0 multiplied by 1 plus, here from now we have to go from to the right hand side of the decimal. So this is 2 to the power minus 1 multiplied by 1 plus 2 to the power minus 2 multiplied by 0 plus 2 to the power minus 3 multiplied by 1. So this is 2 to the power 2 is 4 plus 2 plus 2 to the power 0 is 0, 1. So this is 1 by 2 plus 0 plus 1 by 8. So this is 4 plus 2 is 6, 6 plus 1 is 7, 7 plus zero point 0.5 plus 0.125, I think 1 by 8 is 125. So my answer is 7.5 to 5 plus 1 is 6, 7.625. So option C, this is 111 0.101 and 7.625. Option C is our correct answer. So any doubts regarding this question? So I can see no doubts. I can move forward to the other question, that is question number I think 10. This question number, no, 9, question number 9. Why is it? Wait, just a moment, just a moment. Just a moment. Just a moment. Sorry for this hiccup. So this question number 10 asks us to convert this 124 number, which is in decimal, to base 4 number system. So what we have to do is we take up this number 124 and divide it by the base of the number system, that is 4. So this is 4, this 431. 431 is 430 is 120. 431 is 124. So and remainder is 0. Then we will again divide this by 4. This is 47 is 28 and remainder is 3. Then we will again divide it by 4. It is 4 1 and remainder is 3. So our number is 1330 to the base 4. So option B is our correct answer. I hope there are there any doubts in this question? This was a pretty straightforward question, so I think there are not any doubts. I can move forward to this question number I think 10. Question number 10. Why is it coming up again and again? I don't know why. It's coming up again. I don't know why it's coming up again and again. So we have this number 36 to the base 7 and we have to convert it into the number system base of number 5. So what we will do here is first convert this 36 into base 10, that is decimal number system. So what we do is 7 raised to power 0 multiplied by 6 plus 7 raised to power 1 multiplied by 3. So our number in decimal system would be 21 plus 6, that is 27. And now the question asks us to convert this we convert the number into base 5 system. So what I will do is I'll take up this number 27 and divide it by the base of the number system, that is 5. So 5 is 25 and remainder is 2. 5 1 is 5 and remainder is 0. So my number is 102 in 5. That is option A. This was also a pretty straightforward question. I think we can move forward to this. Another question, question number 11. Why is it coming up again? I don't know why. Maybe I have messed up something. Yes, I'm doing some issues. So there are some people who want to join in. I'll just admit it. So we can move forward to this question number 11. This question number 11 wants us to add to these binary number using ones complement. So what we will do here is take up this positive number as it is, that is 1, 1, 1, 0, and at its sign bit it is 0, and this negative number that is minus, sorry, minus 1, 1, 0, 1, and take its ones complement. So ones complement is basically just take up all, just change ones to zeros and zeros to ones. So the ones complement of this 1, 1, 0, 1 will be 0, 0, 1, 0, and the sign bit is represented by 1. Now we will add them up. So the 0 plus 0 is 0, and 1 plus 1 is 2, so this is 1, 0 as I told you in the earlier slides, and we have this carry 1. 1 plus 1 is 2 again, so we have this 0, 1, 0, carry 1. 1, 1 is again 2, we have this 0 and carry 1, and this is 1, 1 again, this is 1, 0. The carry that I got here is added to the LSB. So we have this number 0, which signifies the sign of the number, and then we have the final answer, that is 0, 0, 0, 1. So this 0 here means positive, and our number answer will be, final result will be 0, 0, 0, 1. So I think it's option D. So option D is our correct answer. So any doubts regarding this question, question number 11? Because, yeah, please, you can just type in your question. I got your question. Yeah, Ranjit, I'll repeat it. Yeah, I'll repeat it. So we are asked to find the sum of following binary numbers using ones complement. So question asks us to find the this sum using ones complement. We have this number, positive number, 1110, 1110, sorry, 0, and we have the sign of the bit, that is 0. And then we have this number minus 1101. So when we do this addition using ones complement method, we take up the ones complement of the negative number. Since the negative number here is having the less magnitude, so we will just take the ones complement. So the ones complement of 1101 is 1 changes to 0, 0 changes to 1, so it is 0, 0, 0, 0, 1, 0, and the sign is 1. So, and when you add them up, so 0 plus 0 is 0, 1 plus 1 is 2, and 2 is written as 1, 0, so 0 here, 1 goes to the carry. Then 1 plus 1 is 2, again 1, 0, so 0 goes here, 1 goes here. So 1 plus 1 is 1, 0, 0 goes here, and 1 goes here. And then we have this 1 plus 1 is again 2, 0. And in this ones complement method, when we have this negative number having magnitude less than this positive number, this one in one's complement method, this carry is not disregarded. As you have already gone through the lectures, you might have gone through the lectures. This one is added to this LSB. So this, then after adding it to LSB, we get this 1, 0, 0, 0, and this here is the sign bit. So our answer is plus 0, 0, 0, 1. So this is the convention how of using this ones bit complement to do the addition. You can just refer the lectures and you can just take another look. If there are any doubts, you can just type in here. Okay, Ranjit. So now let's move forward to this question number 12. So this question number 12 asks us to find the sum of following two negative numbers we have given here in sign plus. So here the question asks us to give us the answer in sign plus 5-bit register using ones complement. So here the both numbers are negative. Our first number is minus 1010 and our second number is minus 0101. So we'll just convert it into 5-bit representation and take ones complement. So our number 1010 ones complement will be 0101, and since it's a negative number, the sign bit will be 1. Then we'll take up this number 010 and take its ones complement, that is change the zeros to ones and ones to zeros. So it is 1010, and our sign bit. So someone is showing a mute. So and then we have the sign bit 1. Now we'll add them up. So 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1, and 1 plus 0 is 1. And this 1 plus 1 is this 2, that is 1 0. So we'll go with 2 and add the what we call as carry to the LSB. In one's complement we add to the LSB. So when we add it to LSB, it becomes 1 plus 1 is 2 1 0, carry 1, 1 plus 1 is 2 1 0 1, carry again. So it goes carry propagates, 1 plus 1 is 2 1 0, and this one comes out to be here. So this here is our sign bit and this here are other magnitude bits. So as we are using this negative number, finding the sum of two negative numbers in sign plus 5 magnitude registers, so we need, for a final answer, we need to take ones complement again of the magnitude bits. So the ones complement of the magnitude bits here means these 4 bits 0 0 0 0. So it's ones complement is 1 1 1 1, and the sign here is 1. So our answer will be minus 1 1 1 1. I think we are doing that answer. That is option B. If there is 0 in carry, that means nothing. 0 in carry means nothing. Sejal, 0 in carry means nothing. So that's not an issue. So any doubt in this question number 12? Yes, sir. I'll repeat. I'll repeat. No issues. So we have given this number 1010. Two negative numbers are there, and we have to find their sum using this sign plus 5 magnitude bit registers ones complement. In a sign 5 plus magnitude bit register using ones complement. So this 1010 with a negative sign is written as, in ones complement is written as, first we will convert it in ones complement, that is change zeros to 1 and ones to 0, that is 0101, and the sign bit here, that is negative, will be 1. Then we take up the another number, that is 0101, and its ones complement is 1010, and sign bit here is 1. Now we will add them up. So I'll just show you the addition again. 0101, 1010, and here are the sign bits. So addition will be 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1, and 1 plus 0 is 1. And this 1 plus 1 is 2, and the 2 is written as 0, 1 0. So 0 will come here, and this 1, since we are using 1 bit, ones using ones complement method, 1 will be added to the LSB. So when we add it to the LSB, so 1 plus 1 is 2, that is 1 0, 1 goes on here. 1 plus 1 is 2, 1 0, 1 goes on here. 1 plus 1 is 2, 0, so here will be 1. 1 plus 1 is 2, here goes 0, and here goes 1. So this is our signed bit, and this is our magnitude bit. So since we are adding two negative numbers, we'll just take up the, and we are using ones complementing, we have to complement the final output we got here, magnitude only. So 0 0 0, it's out, it's what we call as magnitude, and its ones complement is 1 1 1 1. So our answer will be sign bit is minus, and this magnitude bits are 1 1 1. That is option B. Hope I'm clear. Since we are taking up two negative numbers, this is the rule that we have to follow. You can just take up the lecture. In case you have any more doubts, we can just discuss in the next live session. So you just look up the lecture. These are the rules we follow in one's complement and two's complement addition. So I'll just show you one more question. That's the last question. This Jayanti, because the question is asked us to use this 5-bit sign addition. That's we are using this sign bit. So when we are having these two negative numbers, we have to take up the sign bit also. You take up a look at lectures once again. So in case of any doubts, if you reach out to me next time, I'll just clear them up. So now we have to use this final question that I have prepared for today. I don't know what is happening with this. So the final question that I have prepared for today is this. In a 5-bit register, again we have this 5-bit register, find the sum of the following using 2's complement method. So we have to use 2's complement method. Someone is joining. So we have to use 2's complement method. Previously we have used this 1's complement method. So now we will be using this 2's complement method. So we take up this positive number, that is 0, 0, 1, 1, and we'll keep it as it is. So it is 0, 0, 1, 1, and we have the sign bit. Then we have this number minus 0, 1, 0, 1. It's 2's complement. So I'll just show you how to find easy way of finding out 2's complement. Just find the 1's complement. So 1's complement of 0, 1, 0, 1 is 1, 0, 1, 0. And simply, whatever the number would be, first find the 1's complement. And when you have to find the 2's complement, just add 1 to the LSB. So it is 1, 1, 0, 1. So its 2's complement is 1, 0, 1, 1. So I'll repeat this 2's complement here. So we have this number 0, 1, 0, 1. So I'll first find out the 1's complement, that is 1, 0, 1, 0. And once I have found the 1's complement, I will add 1 to the LSB. So I'll get the 2's complement. This is a way of finding out 2's complement. And since it was a negative number, I'll just add the sign bit here. So this is, now I'll just add them up. 1 plus 1 is 0. 1 plus 1 is, sorry, 1, 0. So 1 will go to carry. So 1 plus 1 is 3. So 3 is represented by 1, 1, as you can see. 2, 1, 1. So 3 is represented by 1, 1. So 1 go here, 1 go here. So this 1 plus 0 is 1, and this 1 plus 0 is 1, and this 1 plus 0 is 1. So this here represents the sign of the bit. Now we have to take, since we are using up to 2's complements addition part, we have to take up the 2's complement of the this number, negative part, and we'll get the answer. So this 2's complement of 1110 is, first take up the 1's complement, that is 0, 0, 0, 1, and add 1 to the LSB. So the answer will be 1 plus 1 is 0, 1, 0, and 1 will come here, and it will be 0, 0, 0, and the sign here is negative. So the answer will be minus 0, 0, 1, 0. That is option C. I'll repeat it again. So what I did here is I took up the number, positive number 0, 0, 1, 1, and I took up its 5 representation, that is 0, 0, 1, 1. 0 here represents the sign. Then I took up the negative of the negative number minus 0, 1, 0, 1. I took up its 2's complement. Its 2's complement is 1, 0, 1, 1. How I found out the 2's complement? I first found out this 1's complement, that is 1, 0, 1, 0, and I added 1 to the LSB. This is a way of finding out 2's complement. So I found out the 2's complement. It is 1, 0, 1, 1, and its sign bit is 1. Now I added the two numbers, so it is 1 plus 1 is 2, it is 1, 0. So 1 plus 1 plus 1 is 3, that is 1, 1. 1 plus 0 is 1, and then I have 1 plus 0, that is 1. and this is also 1 plus 0. So this is my science bit. Since we are using up the 2's complement addition, so this number here, the magnitude needs to be taken up 2's complement again. So how will I find the 2's complement? Just like I said previously, we will take up the 1's complement first. That is change 1 to 0 and 0 to 1. So it will be 0 0 0 1 and add 1 to the LSB. So it becomes 1 plus 1 is 0 1 0. So 1 here, 1 plus 0 is 1 0 0. So my answer in 5-bit register using 2's complement method is minus 0 0 1 0. So because we are using this 5-bit register, so 5-bit register means that one of the bits should be sign bit. So I think there was one doubt in this, if I can remember this question. Someone had asked using, I told him to write it in chat box, but he didn't. In this question, I think there was some doubts. So I'll just repeat it again. So the question was asking us to find the decimal equivalent of 1101.011. So 111.111.011. So this is 0, 1, 2, 3. 2 to power 3 multiplied by 1 plus 2 to power 2 multiplied by 1 plus 0 plus 1. Now I'll take up the portion to the part of the right hand side of the decimal. So it is 0 multiplied by 2 to power minus 1 plus 1 multiplied by 2 to power minus 2 plus 1 multiplied by 2 to power minus 3 and plus 1 multiplied by 2 to power minus 4. And when we write these numbers together, it becomes 8 plus 4 plus 0 plus 1, as I have written here. 8 plus 4 plus 0 plus 8 plus 4 plus 0 plus 1, that is 13, plus 1 by 2 multiplied by 0 is 0, 1 by 4 is 1 by 4 is 0.25, then 1 by 8 is 0.125, and then we have 1 by 16, that is 0.0625. So when we add them up, we'll get the answer, that is 13.4375. Yeah, I can show you the last question, no issues. Yeah. So last step here is, someone has asked me to repeat the question. I'll just repeat it again. So this 0011 is written as 0011, and its 5-bit representation. This fifth bit will be represented by this sign 0, and then we have this negative number 0101. Its 2's complement will be by first take up the 1's complement 1010 and add 1 to the LSB. It will be 1011, and the sign was negative, so 1 is here. Now I'll just do the addition. 1 plus 1 is 1 0 0, 1 will be carry. 1 plus 1 is 3, so 1 1 1 will be carry. So 1, sorry, so 1 and then again 1, and 1 plus 0 is 1. Now this is the represent the sign, and we have to take up this number, which is the magnitude. We have to take up the 2's complement again. So 2's complement will be 0 0 0 1 and add 1 to the LSB. So this is the 1's complement, this is the 1's complement, and this one we are adding to the LSB to get the 2's complement. I hope I'm clear. So this was all for today's session. I think you have to submit your assignment up to your deadline is, I think, 10th August. So you can just refer to the site for any details. So we will meet again on next Sunday at the same time. We will be discussing week 2 assignments. Questions related to week 2 assignments, so that it will help your assignments and clear any doubts. So I think that was all from my side. You can leave the meet. Thank you for joining. Yeah, meeting link will be same. Meeting link will, throughout the course, meeting link will be same. So I'll be ending up this meeting. So thank you guys. See you next time. Uh, yeah, Gulshan, next time meeting will be same link, same time. Okay, I'll just end up the meeting. Thank you guys. Thank you for the wonderful session.